When we read empirical research papers, we see many researchers make causal claims that cannot be justified by the evidence in their research. What does causality mean? It means we hold all factors except for their manipulated variable at a constant level. The change in the outcome associated with manipulated factor is called a causal effect of the manipulated variable. To make causal claims, we need a hypothesized cause X and an effect Y. We also need to meet three conditions. First, X must precede Y temporarily. It means there must be a temporal order, X first, Y later. But the temporal order is a necessary but not a sufficient condition. I can eat an apple at 7 o'clock and then read a book at 8 o'clock. There is a temporal order as I eat an apple first and read a book later. But it is an invalid causal claim if I say eating an apple causes me to read a book. The temporal order is a necessary but not a sufficient condition. Imagine that a leader starts working as a president or CEO of an organization or a superintendent of a school district in January. Then in December, the leader gives an end-of-the-year speech to employees, touting all the positive changes in the organization. The leader may say, "Since I joined the organization, I did X, and we see a positive change in Y 1 year later." Or, under my leadership X, my team has achieved Y. Those statements are invalid causal claims because they only establish the temporal order, taking a leadership role first, a change later. Again, the temporary order is a necessary but not sufficient condition. To make a valid causal claim, there are two more conditions that need to be met. Second, X must be reliably correlated with Y beyond chance. This second condition requires a statistically reliable relationship. It is very difficult to make causal claims from qualitative data alone because qualitative methods are generally better suited for understanding and describe phenomena rather than determine causality. We can use qualitative methods to answer how, but it is difficult to answer why by using qualitative findings alone. This doesn't mean that quantitative evidence carries more weight than qualitative evidence. Quantitative evidence may seem scientific and rigorous, but we can easily detect nonsense and the specious relationship between X and Y. Statistical techniques are important. Equally important is how hypotheses are developed. Without using theoretical framework and existing literature to develop a hypothesis before research design and data collection, it is easy to use the collected data to run as many statistical tests as you can until you find a statistical significant relationship. And you only report that significant relationship without mentioning all the other tests you've run. Readers are left with an impression that whatever you report is the only test you ran and all the other tests appear never took place to readers. Third, the relationship between X and Y must not be explained by other causes. This condition is the most difficult one to meet because we have to provide evidence to prove that X varies randomly and is not correlated with omitted causes that are not tested in experiments. The only explanation is the intervention or treatment causing the differences in Y. If a researcher collects data on the leadership behavior and organizational culture from the same data source, for example, from leaders, then there is a common method bias in measurement. Leaders are likely to provide inflated answers because of social desirability or overconfidence, which produces a positive correlation between a leadership behavior and organizational culture. In this case, even if a strong relationship between a leadership behavior and organizational culture exists, that relationship can be explained by the common method variance. Some researchers make explicit statements like X causes, predicts, influences, explains, or is an antecedent of Y, or that Y depends on X. Other researchers shy away from using explicit language and instead use suggestive language like Y is associated with X or Y is related to X. Regardless of explicit statements or suggestive language, to evaluate whether the researcher's causal claims are valid, we need to check whether research designs and results meet the three conditions. If the three conditions are not met, and we see a statement, a leadership behavior influences organizational culture, we should ask whether a reverse causality is at play. We should ask, is it possible that organizational culture is the cause and the leadership behavior is the effect? The gold standard to generate causal evidence is to use randomized field experiments. However, randomization is often difficult to achieve in research design in social science research. To conduct randomized experiments, we need to first use random sampling methods to select a sample of participants in a way that the sample is representative of the population of interest and that any evidence in outcomes between groups can be attributed to the intervention or treatment rather than to pre-existing differences between groups. There are several types of random sampling methods, including simple random sampling. For example, using a random number generator to select participants from a list of all eligible individuals. Stratified random sampling, that is, dividing the population into subgroups or strata, and then select a random sample from each stratum. Cluster sampling, that is, selecting a random sample of clusters or groups from the population and then selecting participants or units from within those clusters or groups. Systematic sampling, that is, selecting participants or units at regular intervals from a list of all eligible individuals. And multi-stage sampling, that is, using a combination of different sampling methods such as cluster sampling and stratified random sampling to select a sample from the population. After using random sampling methods, we then randomly assign participants to the different groups or conditions in the experiment. This helps to ensure that any differences in outcomes between groups can be attributed to the intervention or treatment rather than to the pre-existing differences between groups. Next, we implement the intervention or treatment on the experimental group. The randomized experiments are rare in social sciences, especially in leadership research. In an article titled "On Making Causal Claims, a Review and Recommendation," researchers reviewed a random sample of 110 articles on leadership published in top-tier leadership and management journals between 1999 to 2008. A key finding was that researchers failed to address at least 66% and up to 90% of design and estimation conditions that made a causal claim invalid. In another article titled "In Pursuit of Causality in Leadership Training Research, a Review and Pragmatic Recommendations," published in the Leadership Quarterly in 2021, researchers also reported that a majority of studies on leadership training and positive organizational outcomes did not meet the criteria to make a causal claim. I hope you'll pay more attention to causal claims in leadership research literature and use what you've learned in this video to make your informed judgment on whether those causal claims are valid or not.